Good day, this is Rachel Dijkstras, and for today's lecture, we will going to discuss the Dijkstras algorithm. Okay, for the learning objectives, at the end of the lesson, the student was able to understand basic graph concepts, a quick review, and then the student was able to understand what Dijkstras algorithm is used for, and the student is able to know how it works behind the scenes with a step-by-step example. Okay, let's have the basic concepts. Graphs are data structures used to represent connections between pairs of elements. It is used to represent the different connections of elements. Okay, these elements are called nodes. They represent real-life objects, persons, or entities. The connections between nodes are called the edges. The two terms that we need to remember, the nodes and the edges. The elements are the nodes and the connections is called the edges. This is the graphical representation of a graph. We have here node 1, node 0, node 2, and then node 5. These lines are the edges, or these are used or the connections. Okay, next. Nodes are represented with colored circles and edges are represented with lines that connect these circles. Okay, for the applications, graphs are directly applicable to real-world scenarios. Okay, for example, we could use graph to model a transportation network where nodes would represent facilities that send or receive products and edges would represent the roads or paths that connect them. Okay, we have this illustration. Okay, this one. This one, okay, from node 1, node 0, transfer to node 1, no, it is used to transfer the facilities. Node 1 to node 2, and then node 2 to node 3. So, this is one of a real-life scenario example. Real-life example. Okay, another example, we have common example in a Facebook. Diba? Common example, it includes persons. We have different friends on Facebook. And then we have another example, the family. We have the cousins, relatives, and so on. There are a lot of cases. There are a lot of examples that we can see that graphs are very applicable. Okay, we have types of graphs. Types of graphs. Graphs can be undirected. Okay, undirected. We have undirected. Undirected graph, if for every pair of connected nodes, you can go from one node to the other in both directions. Okay, we have here the undirected graph. Node 1 can go to node, and node 0 can go to node 1. Or it could be that node 0 can go to node 2. Or it could be node 1 can go to node 2. Node 1 can go to node 3. That is undirected graph. And then, for the directed graph, for the definition, we can say that it is a directed graph if for every pair of connected nodes, you can only go from one node to another in a specific direction. We use arrows instead of simple lines to represent the rectangles. Okay, directed graph, we have a specific directions. To know more or to identify better, if it is a directed graph, we use arrows for the specific directions. We have node 0 to node 1, node 1 to node 2, and then node 1 to node 3, and then node 3 to node 2. There are arrows that is used to identify, or much better identification, that we have a specific direction. Next, we have weighted graphs. Okay, definition. A weight graph is a graph whose edges have a weight or cost. The weight of an edge can represent distance, time, or anything that models the connection between the pair of nodes it connects. Weighted graphs, the weight of the graph, it could be the distance, the time, or anything that models the connection. Okay, we have an example here. We have, for example, in the weighted graph below, you can see a blue number next to each edge. This number is used to represent the weight of the corresponding edge. Okay, 2, 5, 9, 8, and 6 are the weight of this graph. Okay, these weights are essential for Dijkstras algorithm. You will see why in just a moment. Okay, we tackled the graph, the basic concept of graphs, the types of graphs, because it is very applicable, it is very useful in understanding the Dijkstras algorithm, or the shortest path algorithm. Okay, we have the introduction to Dijkstras algorithm. Okay, now that you know the basic concept of graphs, let's start diving into the amazing algorithm. We will know the purpose and use cases of Dijkstras algorithm, the history, the basics of algorithm, and then the requirements. We have the purpose and use cases. With Dijkstras algorithm, you can find the shortest path between nodes in a graph. Particularly, you can find the shortest path from a node called the source node to all other nodes in the graph, producing a shortest path tree. This algorithm is used in GPS devices to find the shortest path between the current location and destination. It has broad application in industry, especially in domains that require modeling networks. In real life, this Dijkstras algorithm is very useful, most commonly broad applications in the industry. As a short review on the history of Dijkstras algorithm, we have this algorithm was created and published by Dr. W. Dijkstras, a brilliant Dutch computer scientist and a software engineer. In 1959, he published a 3-page article titled "A Note on Two Problems in the Connection with Graphs," where he explained his new algorithm. Dijkstras algorithm is named after the one who created, the one who published it, which is Dr. W. Dijkstras. Okay, we have the basics of Dijkstras algorithm. Dijkstras algorithm basically starts at the node that you choose, the source node, and it analyzes the graph to find the shortest path between that node and all the other nodes in the graph. The algorithm keeps track of the currently known shortest distance from each node to the source node, and it updates these values if it finds a shortest path. Third, once the algorithm has found the shortest path between the source node and another node, that node is marked as visited and added to the path. The term visited is very important because it represents that if the algorithm has found the shortest path, then it has marked as visited. Next, the process continues until all the nodes in the graph have been added to the path. This way, we have a path that connects the source node to all other nodes, following the shortest path possible to reach each node. Okay, next, we have the requirements. As the requirements, Dijkstras algorithm can only work with graphs that have positive weights. This is because during the process, the weights of the edges have to be added to find the shortest path. If there is a negative weight in the graph, then the algorithm will not work properly. Once a node has been marked as visited, the current path to that node is marked as the shortest path to reach that node, and the negative weights can alter this if the total weight can be decremented after the step has occurred. Therefore, as the requirement, it is very important that our graph is have a positive weight, because if it has a negative weight, then it does not work. Then the Dijkstras algorithm is not applicable in that type of graph.